Hey everybody. So today I'm going to talk about the points view and the new cleaning tools that I've added in Kluster 0.8.0. So with the points tool, basically we're going to drag a box here in the map view. It's going to cover some of these soundings. You see I've got two lines in a grid shown here. And all the soundings in the box are going to show up here, and we can examine them and clean them in 2 or 3 dimensions. That's the basic idea. So with this selected, I'm going to go up here, the points tool, and you can also mouse over to get these directions. I'm going to click once, and it's going to set a rectangle. I'm going to click twice, and it's going to set the other corner of the rectangle, so now it's fixed. I'm going to hold Control, and I'm going to rotate it by just moving the mouse while holding Control. And then I'm going to let go of Control, and it's going to be fixed. And then I'm going to left click, and it's going to load these points in this points view. So you'll notice that I rotated this selection box thing to be aligned with the track line. And that's because when you view in 2D view, which I'll show you, you basically want this rotation, this rotated box, to follow the track line so that you can see the soundings as they're seen in acquisition. So it sort of makes sense to you when you see it. You'll see that when these lines aren't run northeast or north-south or east-west, you have to rotate to get a good sense. The 2D view is kind of strange, which is why I'm going to start with 3D view to give you this intuitive sense. So here you'll see we have this point cloud, and it's basically this, right? You'll see the box. You'll see this cutout of this is now over here. And we have all of these little dots, and these dots are the soundings, or the beam returns from our multi-beam sonar. So I'm moving around here. If you want to figure out how to use this thing, you can mouse over this box down here, and it'll give you all the instructions I'm about to go over. So basically you can left click and rotate the camera. You can right click and zoom the camera. You can middle mouse wheel to wheel zoom in and out. And you can hold shift and left click to translate the camera center or move the center of rotation. So you see I'm rotating around here. I hold shift, I left click, and I drag. Now I'm rotating around here. So if you want to center the camera on this feature, for instance, right now I'm rotating around the feature. And that's how you interact with this camera. So let's go over these controls up here. These are all pretty self-explanatory. You can color your soundings by depth, where, up here, these are, 3 meters. Down here, these are like 7. You see the color bar here sort of explains the colors. You can color by vertical uncertainty. You can color by the beam of the return. You can color by the rejected state, so we'll talk about this in a sec. You can color by the system, which is this container here. There's only one, so there's only one color. And you can color by line name. So there's 2 lines. You'll see them here in the map. They're both in this box. And here are the soundings associated with each line. So this is nice because you can really tell which line is which in this point cloud. So I'm going to go back to rejected, because what I'm going to talk about now is selecting soundings. So you can select or query points by holding Control and dragging a box. So I've selected these soundings up here. They've turned pink. And now in the Explorer window, you can see I have all the attributes of these soundings. There's 4 from here, 4 from here. You can click, and the one that you clicked turns white up here. It's kind of hard to see, but this really lets you pinpoint a sounding if you want to know exactly what's going on with this one sounding. Okay. The other thing you can do now is you can clean points. So right now we're coloring by this rejected state. So all the points that are red are rejected, which means that they're not going to contribute to the grid that we build. So if you have some noise, say up here, this is already rejected because it's red, but you could clear it out and then it wouldn't influence the grid. So if we have stuff behind here we want to get rid of, you can hold Alt and left mouse button and it's going to reject these soundings. Alt, left mouse button. Alt, left mouse button. If you have rejected soundings that you want to accept, you want to get them back into the data set, you hold Alt and you right mouse button and they turn this teal color. These are reaccepted soundings. That's a bit dangerous. Maybe over here. Okay, so now these are back in the data set, so the grid will use these soundings. And then if you hold Alt and you middle mouse click, it's going to undo your changes. So you're going to see all my changes are sort of going to undo one by one as I click. And that's the gist of it. I think from here, I did want to mention, so a lot of times you might want to hide rejected soundings. So if you click that, you can interact with this data set, rejecting soundings, and they just go away now. Rejecting doesn't delete anything. All I'm doing right now is I'm just hiding the rejected soundings. That way, if you want to clean by, say, some other attribute, let's say you want to clean by uncertainty, you want to filter out points that have a high uncertainty, you can go in here, reject them, and they go away. Okay, I kind of like leaving it on myself. So let's go and examine this in 2 dimensions. Actually, I did want to mention one other thing. This vertical exaggeration is kind of a weird thing, so I wanted to mention it. There's no way really of stretching with the mouse, stretching this view, so you get more exaggeration in the vertical sense. So you sort of have to just dial it in here. So you'll see that as I increase this number, it sort of stretches up, right? It scales up. I like 3. Yeah, 3 seems to sort of make sense. The reason why you want this at all is you'll see if I bring it down to 1, which is like the quote-unquote accurate depiction, it's hard to get around here, right? If I want to just query parts of this, if they're exaggerated, it's easier to get your mouse in there and select a region. Okay, so let's switch to 2D view now. So with 2D view, you can do basically all of the same things. There's the color by, things change, right? Just like before. There's this view direction. So I mentioned before that you want to rotate this box to follow the track lines. Well, if I view by north, I'm just seeing this box viewed in the north. So it's showing the eastings versus depth. If I view it to the east, it's viewing this selection from the east, so it's showing northings versus depth. Where if I view it by the arrow direction, it's rotated in the way that shows the feature the way it actually appears during acquisition. So that's generally what you want to do, is point this thing along the track line and view with the arrow direction in 2D if you're doing a 2D view. And again, 2D is a bit complicated. It's like not intuitive. You're compromising in order to build this thing, to show it in 2 dimensions. Okay, but I think I've gone off on that enough. So you can do all of the same things. Again, you can hold Control and select. You can hold Alt and clean points. If I show rejected, clean points. You can do all of the same things. The big difference is that, and I didn't go over this initially, but you can use the mouse differently to control this. So left mouse now moves this little slice around. Right mouse scales So no need for vertical exaggeration. I can just click right mouse and move up, and I'm introducing vertical exaggeration. So this is kind of nice because you can just make it whatever you want. And then mouse wheel to zoom in and out. Okay, so I've gone at length about cleaning and selecting soundings. So let's talk about one last thing before I wrap this up. We've been talking about how soundings can influence the grid. So how do we actually take this grid and update it for the changes we've made in our soundings? Well, first, let's do something crazy here. Let's just reject this whole thing. Okay, we've cleaned every point in this box. Don't ever do this, but we're just doing a demonstration here. If I go over here and I update the surface, this is basically saying we have one of these converted containers in this surface. There's an asterisk, and that tells you that this container has changed since you made the surface. Now, how could I possibly know that? Well, if you click and you look at these attributes, you'll see there's this soundings last cleaned date. So this reflects the last time you made a change here. It'll update this date here. And then the grid itself has a date, and it just compares the dates. So it's actually not that complicated. If you make changes in the soundings in the multibeam data, this will know, and it'll say, here's an asterisk, this needs to be updated. And then if I hit OK here, the grid is going to update, reflecting the changes I made in the soundings. I have to click here to update it. And you'll see, look at that. This whole slice is now gone because we've rejected it. But again, I want to emphasize these soundings still exist. In fact, I can do a quick points view. And you'll see, right, the soundings still exist. They're still there. We didn't delete anything. We just marked them as rejected, such that when we do our gridding, they're ignored. So that's the key point here. When rejecting is they're just ignored during the gridding. Okay, so that's the end of this update. Thanks for watching.